Okay, this video is for lesson 4, both day 1 and day 2. A lot of you were missing for day 2, so please tell your friends that they need to watch this video if you are watching it right now. Day 1 technically was supposed to be both of these examples. We actually only did this one. I went over example 2 in our day 2 material. So I left my extra packet at home, so I just copied the questions onto the back. This is in your part 2 packet. And it's like the second to last page. Last-ish page. So when we are adding and subtracting like denominators, that means, hey, these values here in the bottom are denominators, they're the same. So what we do is we actually follow this rule that says, I'm going to just write it down here, A over C plus B over C is just an A plus B divided by C. So our denominator just hops right over and becomes 1. So what we're going to do for this one is we're just going to say, okay, that 7 plus 3 on the top is just going to become that 7 plus 3 divided by 4x. So that means our final answer is just A10 divided by 4x. These ones are pretty quick, straight to the point. For our next one, the only thing that's tricky is the fact that there's this negative here. If there were multiple terms up here, you would need to make sure you were distributing. It affects everything that's in the numerator, all the way down, no matter how many terms you have. Luckily, this one there's only one, so we're going to end up with is just a 2 minus 5, and that's going to be divided by that x plus 6. So final answer here, negative 3 divided by x plus 6. So technically that's following the same rule here, except for saying, oh, A over C minus B over C is just equal to A minus B divided by C. Alright, so example 2, adding and subtracting with unlike denominators. This is where it gets a little bit trickier. So we didn't spend a lot of time on this in class, so I'm going to go through it in some good detail here in the video. So for this first example, I'm looking at these denominators and they're not even close to looking the same. So what I'm going to do is I need to look at that least common multiple, because I want my denominators to be the same. So I'm going to look at this first one, the 9x squared, and I'm going to say, okay, well, what is that made up of? What's basic pieces? Well, I know 9 can be broken up into 2 3s, and the x can be broken up into 2 x's. Next, I have that 3x squared plus 3x. Well, these both have a 3, and these both have an x, so I can do the opposite of my distribution. I'm going to factor that back out. So it could look like a 3 times x times, well, if I take the 3 out and an x out, that leaves 1 x behind there. And if I take a 3x out of a 3x, well, when I divide that out, that's just a 1. So what I'm noticing here is that, okay, I have 1 3 and 1 x in common, but they're missing these 3x up here and this x plus 1 here in common. So what I'm going to do is up above, this first term is missing this x plus 1. So the way we're going to write this is we're going to say, okay, the 7 divided by the 9x squared, I'm actually going to multiply it by whatever I'm missing down here. So in that other denominator, it has this additional piece that this one doesn't. That is what I'm going to multiply by. The x plus 1 over x plus 1. You also have to make sure you're doing it as technically a multiple of 1. So technically we're just multiplying by 1 here, because these cancel each other out. That way, that looks kind of weird, multiplying by 1. That way when we do this, we're not actually changing the value of that fraction. Next, that's still going to be plus, and we're going to have that x divided by the 3x squared plus 3x, but now it's going to be times Well, it's missing the 3 and it's missing an x, so 3x and 3x. We're still just looking at that other denominator and saying, okay, what does this have that this one didn't? That is what I multiplied by. So now, when I multiply here, I'm going to take this 7 and I'm going to distribute it, because we're multiplying here. So I'm going to have a 7x plus 7 divided by, once again, I am distributing this 9x squared here. So a 9x cubed plus 9x squared. And this is plus a 3x squared divided by, well, if I distribute this here, I get to the same thing I had over here, which means I found my common denominator correctly. So always make sure you're distributing both, because that's going to be kind of one of the few checks you have to see if you're doing this correctly. So here we'll still have that 9x cubed plus a 9x squared. Now that those match, oh, I just follow the same rules we had up above. If I add these, I'm going to bring it into standard form, so I'm going to bring my square up front. I have a 3x squared plus 7x plus 7 divided by 9x cubed plus 9x squared. Be careful, you can't just bring that up if there's a minus sign. This is only for addition that you can go straight to that. Normally you would just say, okay, I have a 7x plus 7 plus a 3x squared, keep it in order, and then you could change it around if you wanted, if you're not as comfortable with these. So that would be our final answer here. You can hear my cat, it's fine. For B, we're subtracting this time. We're still going to do that thing where we're saying, hey, we're factoring this. I'm just going to draw a line here to make it clear. If it works better for you, another way you can think about it is you can just write it down below. You can say, okay, well, this is the same. They both have 2. I can pull a 2 out. So this is a 2 times an x plus 1. So if I divide each of those by 2, factor that out. Well, this one, I could factor. I'm going to use a t-chart technically, or box method, whichever you prefer. We want to multiply to 3, but add to negative 4. So that's going to be a negative 3 times a negative 1. So this is saying, okay, I have an x. Did I copy this down wrong? Hold on. Sorry, yeah, there should be a minus sign here. Minus. So we have an x minus 1 then. X minus 1 and an x minus 3. Minus, and that's our 1. So that means they have this x minus 1 in common, but some of this is different. This one, in order to match over here, it doesn't have the x minus 3, so this needs an x minus 3. This one needs, well, it has the x minus 1 already, it needs the 2. So what that's going to look like down below is I'm going to have an x plus 2 divided by 2x minus 2, and I'm going to be multiplying by what it needs still. What's different? That x minus 3 divided by x minus 3. So this is that additional part that we're adding on to get that common denominator to use this rule to add and subtract. Then I have minus, well, I have the negative 2x minus 1 divided by an x squared minus 4x plus 3 times a 2 over 2. So I think this is where it's a little bit easier to see that, oh, I'm actually just multiplying by 1. Because 2 divided by 2 is a 1. Now, here, make sure you're distributing if you're going to factor it out. Here you could use your box method to multiply. Here, we can distribute. Now, I'm going to go ahead and keep these factored actually. So I'm going to write my bottom part in these factored forms, because I'm going to look for things that can cancel out hopefully once I have subtracted them. So here, what I'm going to do is I'm going to have an x plus 2 times an x minus 3 divided by, and I have a 2 times an x minus 1 times an x minus 3. These we don't want to cancel anything until we have already subtracted it, so be careful there. Then this is minus a negative 2x minus 1 times 2 divided by x minus 1 times an x minus 3 times 2. Remember, don't cancel these out until we've added and subtracted. So, yeah, actually I am going to go ahead and factor those, I think, not factor, expand. So what we're going to have is I want to keep it factored on the bottom, but on the top I want to expand it so that way I can combine my terms here. Sorry, I got a little mixed up in that long day. X minus 3 stays on the bottom. I can combine these now though because they're the same. Sorry. Okay. So on the top, if I oh my god, expand this out, I have an x squared minus x minus 6. Then, for this one, I am subtracting a negative 4x minus 2. So here, this negative is going to distribute to both of these terms. So now, I actually have an x squared minus x minus 6 plus 4x plus 2. Final thing, combine your terms, and we see if we can factor this again and cancel anything out. So, long process, I know, deal with it a little bit. It's tedious, but good to know. X squared, well, if I combine these here, I end up with a plus 3x, and the negative 6 plus 2, that becomes a minus 4, all over the 2 times x minus 1 times an x minus 3. Well, if I factor the top here, I actually end up with an x plus 4 times an x minus 1, oh, that 2x minus 1 times an x minus 3. So I can cancel these out. Final answer is an x plus 4 divided by, well, if I factor this 2 into here, it's a 2x minus 6. So, little tedious, you need to know it for your test though. And overall, these are skills that you need to be able to do going forward in your math. Just keep working. The key things with these problems is persistence. There's a lot of steps, but none of them are too crazy. You're just multiplying, adding, dividing. So stick with it. Next, we went into our new packet. So, Unit 8 Notes, Part 3. Now, with this one, this has a little bit of Lesson 4 in it and Lesson 5. These are both lessons that are on the test, and we just started it on the 16th today. We need all of this to get to our unit test. So if you have that goal, saying, hey, I need to get an 80 on this if I want to pass Miss Dunnigan's class, you need to make sure you're getting these notes in. So, flip this open. You'll see day 2 stuff for adding and subtracting. These ones, if you thought the last ones were tedious, you're going to love. So, we are dealing with our complex fractions again. It's saying if I have an a divided by b divided by a c divided by d. But now we're also adding in some adding and subtracting into it. So really we're saying, okay, I have an a divided by b divided by a c divided by d plus an e divided by f. So I have to go through and add these together first. So if I stick with the metaphor, I have to, not metaphor, example, I have to get it so they have the same denominator and add them together. So it would really look like an a over b divided by a cf plus de all over a df. Now I can go through and multiply by my reciprocal instead. A divided by b times df divided by cf plus de. So it's really gross, and then all of a sudden you're like, oh, I'm here. That's not bad. I'm just multiplying across now. So once again, it's just one of those problems you kind of have to stick with. So technically there's 2 methods. You can simplify the numerator and denominator, get it as a single fraction, then divide. or you can multiply by the numerator and denominator by the least common denominator of every factor, then simplify it. I like method 1 personally. Just get rid of it, make it addition, boom, multiply. So here, example A. What I'm going to do first is I'm just going to rewrite this a little bit so it doesn't look as gross. Really, I have a 5 divided by x plus 4. And I'm going to use my division symbol and be like, okay, that's divided by, well, I need my brackets or parentheses here, a 1 over x plus 4 plus a 2 divided by x. Now I need to go through and add these together. So if I'm adding these together, I still need to say, hey, what do these have in common? What do they don't? Well, there's nothing in common, so what I need to do is just straight up multiply by the opposite denominator. So in this case, what that is going to look like is I'll still have the 5 over x plus 4 divided by, but now my 1 over x plus 4, I'm going to multiply this by an x over x. And I'm going to have plus the 2 over x, and I'm going to multiply that by the x plus 4 over an x plus 4. So what that's doing is getting it so I'll now have those matching denominators. And I'm not going to factor those denominators yet, not factor, expand. I'm going to keep them how they are. So 5 divided by x plus 4 is divided by now. Well, up here I just have an x divided by an x plus 4 times x. And here I have a 2 times x plus 4 divided by x times x plus 4. So I'm just going to combine that into one fraction already, the x plus 4 times x. And on the top I'm going to have this x plus, I'm actually going to distribute this here. So we want to keep our denominator fully factored, but in the numerator we want to combine all our terms, so I'm going to distribute that here. Plus a 2x plus 8. So now I just need to take my reciprocal and multiply instead. So 5 over x plus 4, what was in my numerator before is now going to go in my denominator, and I'm going to combine these two terms here. So I have a 3x plus 8 in my denominator now. In my numerator, I'm going to have that x plus 4 times x. Nice thing with this, these x plus 4 cancel because I'm multiplying now. So our final answer is going to be a 5x divided by a 3x plus 8. So there are 2 practice problems here. These are plus 2 on your homework for lesson 8.4 if you get them done for me by Monday. Remember, homework, summative, it's basically going to really help make or break your grade. So get it done if you want to pass. This is where lesson 5 starts, so I'll have a video up about that starting tomorrow. First part's pretty nice and comfortable. It's going to be some review, so look forward to that. You're gonna be like a breath of fresh air after all this tedious, just long. Like, look at this. Okay. Make sure you come up in the notes. We do have that unit test next week on Wednesday.